Third question. Give an example of a divergent series whose partial sums form a bounded sequence. So, to do this question, you need to see this theorem. So suppose, we have this is sequence of partial sums. Sn equals to the sum of ak from 1 to n, where ak is more than or equal to 0 for all k. Then Sn, which is the partial sums, is a bounded sequence if and only if the sum of ak converges. So now what we want to do is give an example of a divergent series whose partial sum form a bounded sequence. So we have Sn bounded, but we want the sum of ak converges. We want the sum of ak diverges. So the example that we choose cannot be a series which ak are all more than or equal to 0, right? Because if ak is more than or equal to 0 for all k, and the partial sums form a bounded sequence, then it implies that the series converges. So the example that I choose must violate this. Must violate this. So maybe the easiest example to choose, let's say, ak is equal to minus 1 power k. This is not more than or equal to 0 for all k. And we can see that the sum of ak, k from 1 to infinity, is actually the sum k from 1 to infinity of minus 1 power n, and this diverges, right? But the partial sum is bounded. This is a1 plus a2 plus a3, so on until an. This is either 1 or minus 1 or 0. It will be minus 1 if n is odd, and it will be 0 if n is even. So we have a divergent series whose partial sums form a bounded sequence. This sequence, Sn, is bounded, right? It is either minus 1 or 0. So we are done.